This is a presentation done by Shadrach Kwejo Dogbaji, index number 2425 400 710. Student of GCTU program BSc Data Science and Analytics. And my presentation is on memory mapping and its associates. So, memory mapping. In computer architecture, we learn that uh, computer is comprised of many different aspects. One of the many different things that a computer is made up of is the memory. And then we learn about the relationship between the memory and how the memory interacts with the CPU of the computer. And we know that in the CPU of the computer, it also has a memory. So to be able to facilitate the relationship between the main memory and the other memories that are in the CPU for processing, we came up with the memory mapping techniques. So what is a memory mapping technique? It's a method that is used to in mapping. When you say mapping, that's um, relating relating two things together. So in memory mapping, it relates the addresses between different memory levels. And the memory levels, you have the main memories, you have the cache memory, and then the main memories and the cache memories, the ad and many other different types of little small faster memories in the CPU. So the different types of memory mapping techniques that we have, you have the direct mapping, the set associative mapping, and the fully associative mapping. Then we also look at cache mapping technique, and then cache mapping is a subset of the memory mapping. It's also found in memory mapping. It's similar to memory mapping, but it focuses mostly on the cache itself and then the main memory. It focuses mostly on the cache and the memories. So yes, it's the techniques that can be used for it as well are the direct mapping, the fully associative mapping, and set associative mapping. Then come to look at the first mapping method, the direct mapping. So direct direct mapping, it's a method. It matches each memory block to one cache line. Matches each memory block to one cache line. So it is divided into the tag, the index, and blocks offsets. So what are the advantages of this mapping technique? Yes, it allows accessing the memory simple and fast by reducing the search time. And then a disadvantage is that it presents problems of conflict misses. Conflict misses means when a mapping is done wrongly, it affects other following mappings or other processes, bringing about delay in memory accessing. So we look at another one technique, the fully associative mapping. So this mapping technique allows for any memory block to be placed in any cache line. It allows for any memory block to be allocated into any cache line, unlike the direct mapping technique that has to be a direct mapping from one to one. This one can allow for the mapping to go from one to many, or from any anyone to anyone in a different domain set. It's also divided into tag and block offsets. The advantages this tech of the technique of mapping, it's due to the fact that it can map from any memory block to any cache line. It prevents issues of complete misses. That's an advantage. And a disadvantage is the process is slow. This is because for memory to be read, different memory blocks and different cache lines have to be read to be able to get the exact mapping that is done. And then the technique requires expensive hardware. Each and every cache line reading requires a different or separate computer. So that is why the technique requires expensive hardware. So we move on to the next uh, mapping technique, the set associative mapping. The set associative mapping came from the combination of the direct mapping and then the fully associative mapping. It's also divided into tag, set index, and block offset. The advantages is that it has little conflict misses. It is and it's also faster. This is faster. A disadvantage is it is very complex. Yes, the mapping is very complex. It's not as simple as direct, and it's more complex than fully associative. Thank you. So that's the end of my presentation. Thank you.